Hello, good morning. In this today's session, we will be discussing about the processing of telecommunication data in call data analysis and management system. Before we go on, standard disclaimer that all data used in this demonstration has been randomized, and the data presented in this webinar is fictitious and for illustration purposes derived from real world scenarios, and it doesn't have any connections without limitations to person, organizations, numbers, IMEI, IMZ, or any circumstances except by coincidence, which we are depicting in this demonstration. Okay, let's move on. So this is the primary login interface. Here we can choose in what type of database we want to go in. So CDAMS basically works in standalone mode as well as client server mode in a local area network. So let's click on it. So there is a dual authentication. One is the hardware lock, so that the software can be used only by the authorized individual who possess a hardware key, which is a hash-based key, and of course the user ID and password, and log in with admin credentials. Okay, once we log in, what we have got is the user dashboard. So currently we do not have any cases inside the system, so we'll create the cases and we will define import specification, then we'll do other things. So let's see something about the user interface. So we have a tree based menu and the top standard menu for different modules, which allow us to process different types of data. So in this demonstration, we will process the standard call data recorder or IMEI scan data. So let's create a new case. So this case ID is generated by default. Let's say CDR demo, and we can choose a crime type. Let's say anti-terror-ops. What type of data we want to process, we will select in these modules, whether it is call data record or tower dumps or mass dumps, or it is ISD dumps, or it is ILD gateway scans, or these are the forensic extractions extracted from UFED, XRY, etc. So let's save this. So case is saved. Close. Now now we will import our data which we request from the telecom service provider on various bases. It may be on the basis of IMEI, it may be on the basis of IMZ, it may be on the basis of MSISDN, which is the mobile number. So each provider provides this data in different format. So for CDAMS to understand this format, the user has to define import specification, and it has to be done only once. You need not to do it again and again, and you only need to modify it when service provider makes any significant changes in them, like changing the order or changing the format, like changing the time format from 24 hours to 12-hour format, etc. So I'll quickly define import specification for a particular service provider. That's a Vodafone. So once we open the file shows some of the preview lines. So you can see this is a tabular data. So we have A number, B number, date, time, duration, first cell ID, IMEI, IMZ, etc. So let's define this import specification. So since this data belongs to India, so my country, defined country is India. So India has been divided into various telecom region because it is a big and large territory. In certain countries you will find only one region, like Bangladesh or Nepal or Bhutan, or certain European countries. You will, since they have less population, so they maybe have a single or a few regions. So let's say this data belongs to Rajasthan region, and within Rajasthan region there are multiple service providers which are operating. So let's say this is for Vodafone. Now let's choose the header row. In this case it is row number 2. So we are telling that okay, anything above row number 2 we can discard off. So let's do this. So A number is my first number, B number is my second number. It's just like source fields are fields from my file, and destination fields are from my database. So date will be mapped with date, time, and this we have to do only once. There's no need to redefine it again and again. So it's pretty straight stuff. Okay, also let's define the roaming circle. If my target goes into a different region, then we can have those things up. Now let's next. Now it will detect whether my target is running into different columns or not. So you can see that when my target is making outgoing call, he is in first column, and when he is making incoming call over here, INC, in the second, then he swaps to the second column. So if I click here, the system detects that okay, target is in both columns, so that in final when entering into the database, it will resolve target into a single column. So date will be date month here, it's 24 hours, all in second. So it will give a unique name that I'm making this specification for India, Rajasthan, Vodafone, and in Vodafone also the delimiter of the file is pipe, because Vodafone may provide you next time tab separated data or comma separated data, or maybe some Excel file, or maybe HTML file, etc. So it's important that what type of data is in. So we entered this information into the specification itself, so that it becomes very easy for users to identify it. Okay. Oh, okay. It says this specification is already existing. Fine. Let me define then for something else. Maybe Airtel. Okay. Region, Rajasthan, service provider Airtel, header row. Fine. So the same thing which we are doing, so basically we are mapping the fields, and this we have to do only once. We need not to do it again and again. Let's select call type, email ESM. Oh, I mapped it wrong, so let's bring it here. So it's IMEI, and this is MZ, and roaming network we can put it in a roaming circle. Fine. Checked. Date month here, 24 hours, all in second. Bingo, saved. So now we had defined our import specifications. So next thing which we need to do is we will be importing this data. Okay, so let's import the CDRs. Okay, so let's say what data is available here. So what I'm doing is I'm just trying to select the directory where I have the data. So let's say I am having data from different service providers, say Vodafone, 3 files from Vodafone, mapped. Airtel, 5 files from Airtel, mapped. Aircell, 1 file, mapped. So we can process data from multiple service providers, and that too for different regions in single go. So let's hit the start button, so it will start processing the data. So now what it is doing is it is transforming data, like bringing date into standard format, time into standard format, formatting the mobile number also. Sometimes they may have a country code, sometimes they may not have a country code, sometimes they may have certain prefixes like plus 00, etc. So it's basically transforming all those things and we have quite a good speed of transforming this data for CDR data. It's around 500 to 700 lines per second, and in ISD data or gateway data, where we process the bulk data, this transformation speed is much more higher, where we process a couple of thousands of lines per second. So now you can see it's uploading this data, and after uploading this data, it will match this data with the existing suspect list or watch list. Okay, so that gives us a benefit. Quickly we can identify that, okay, something is important, the data which we have processed right now, and watch list and suspect list is key in these types of complex investigation, where agencies can maintain the watch list of the high value targets, their associates, their relatives, or their sympathizers, or their supporters, etc. Okay, so let's click OK, and if you want to save these processing log, we can save this, otherwise we can cancel them out. And you can see it tries to match them with the watch list. Okay, so up till now, since we do have a blank watch list, so we do not have anything, but we will be looking this into a different perspective later on. Now let's close this. Now let's enrich it a little bit more. So now we will manage this information. Say we have this a set of data. So what here we can do in information management is, if we had imported some file wrongly into a wrong case, we can delete those files. We can preview those files also. Like if I preview this file, you can see, okay, this is my target, and this particular individual data is available. Now what you see is the cell tower ID address and their latitudes and longitudes, and their azimuth has not been decoded yet. It's because that this data is not available with the call data record. This data is provided separately by the telecom service provider. So we'll upload this data as well. Let's import and say, so this data is for Rajasthan, provider Vodafone, header row 1. So long, we'll go with longitude, this will be latitude, and azimuth, which is basically the sector orientation, and this is address long. This is the full cell ID as in CDR. So my lat longs are in decimal degree. Now let's append this information. Okay, so now all of this information is moving into the database, and we can upload a cell site chart for all telecom service provider of a country. This data is not much because generally one particular region may be having some 30,000-40,000 max cell towers. So we have uploaded around 18,500 records. Now let's try to see. So let's select these Vodafone files. So we have selected these Vodafone files. Go to cell tower ID mapping, India, Rajasthan, Vodafone. So here we have a functionality. One, we can say decode this information from a local machine or a local area network if we are connected, or we can also connect to a virtual private network if the user is in field. So he can connect to the headquarter network over a VPN, and he can decode this information, because taking this information in field may be a bit difficult because of the volume, especially subscriber information. Okay, so once we map this, so the system prompts that and the format in CDR is in this format, and in cell ID chart it is in this format. So it's similar, so we can say no change in CDR or cell ready format. Or if there is a change, then we can use this on the fly transformation options, like decoding last 5 digits or removing the delimiters, etc. Let's apply this, update this information. Now this information is updated. Now let's again preview this information. And now if we preview this information, so you see, now we have address and we have latitudes, longitudes, as well as azimuth. So now this will provide us another dimension where we can send this information into a different look. Now let's basically we can plot this information over a piece of map, like plotting the target location, etc. You can also decode the subscriber information, like from a local LAN or local machine or a remote server. So this information has been decoded. So if we preview, so what kind of data it would have? Yeah. Now let's click OK. Now let's move, and now let's move on to the reports. So what kind of reports we can quickly see while performing this type of analysis. So to go into the reports, we will use this shortcut. Let's say move into the reports. So once we go into the reports, basically it will load up the filters. So if we look in, let's maximize this interface. So here we have our global filters, which allow us to filter information which we have imported on various bases, like we can filter information on the basis of target, or maybe the call type, or maybe the city, state, region, or maybe city, or maybe country, maybe date, time, or maybe the day of week, etc. Or the duration, like if we want to see the calls between a particular duration or greater than or less than a particular duration value, etc. Okay, so let's load this data. So what we have got is around 23,000 records, which has been imported in this particular data set. And you see there are certain numbers which are basically the service messages. Okay, so like when you use credit card, debit card, you may get certain SMS. Sometimes you may get the OTP. Sometimes when you purchase something on online, you may get something get delivered to you. Sometimes you get the advertisement SMS, etc. So let's apply certain exclusion rules. So one rule is, if the number contains alpha character, remove it. If length is less than 9 characters, which is valid for India, all numbers has to be 9 which has to be equal to 10, landline and mobile both. Telemarketing numbers which starts with 91140, toll-free numbers which start with 1800, etc. Let's apply this. Once we apply this particular filter, this system is going to filter these things down. Okay, so now our data is less and we only have this much of data. Now let's quickly view different types of reports which we have in here. So let's say we want to identify frequency based report. So like, okay, this is one of our target, and if I want to identify that, okay, all the other parties on the first column and all other columns are for target. So like this particular target has communicated with this other party for 27 times. So if I want to see the details of these 27 calls, I can drill down here. So all those 27 calls will be listed up here. If required, I can filter things over here also. It is just like Excel like filter, because this is a tabular data, so we can easily work in Excel manner or Excel fashion. Now you can also see a distribution. So if I want to identify, I can see there are certain numbers which are common in 4 targets. Okay, like this particular number is in common in 4 targets, and there have been 35 communications. So this is one way of looking into identifying any common elements. Okay, or there is a direct report for this also, like common number other party. So if you hit, so this will show you that okay, this particular number is common in these 4 targets, and there have been 35 calls. So first thing is, let's bookmark this number so that we remember this. So bookmarks are accessible from here. So what type of number it is, comment, and from which report we bookmarked it. If you want to delete this, we can delete this. If you want to export this, we can export this. If you want to add it into a suspect list, so we can add it into a suspect list, etc. Okay, now let's see the details of these 35 calls. So now if we click, we can filter since this other party has communicated with 4 targets. So 9 times with this, 15 times with this, 5 times with this target, 6 times with this target. So all total calls, 35 calls. And the interesting thing is, all calls are incoming. That means only my other party is calling to targets, but targets are not responding him back. So that's one important thing, that why this person is talking like this. So now once this is done, if required, we can export these reports into different formats like text, CSV, PDF, Excel, HTML, etc., whatever is required by the user. Okay, so now what we were viewing is as a tabular data. The same information we can view as a visual chart also. So we have 2 ways of visualization. One is with IBM i2 Analyst Notebook, other is with the built-in CDAMS visualization. So let's look in. So we can quickly say what type of say conditions we want to put. So let's use icon, identify clusters, etc. And if we want to transfer age by the frequency on edge width, so we can have that also. Let's say generate this. So now this will basically generate a visual graphic chart that will help us in viewing all of this information in a visual visual chart. So that will basically change the perspective in which we view the data. So let's say layout, organic. So these are the different layouts which are available, and these are just like IBM i2 Analyst Notebook. Like this is peacock layout. Okay, so now we can zoom in, and so we can see, okay, this is our one of our target number. The yellow ones are other party, the blue ones are the other party which has been of different countries, and red ones are basically the common numbers. Okay, and when I hover my mouse, you can see the other attributes like their provider, region, country, city, etc. Okay, now let's and we had extracted a cluster out of this also. Okay, so you can see like this. So all data, and you can see there is some interconnection between this cluster also. So let's analyze this cluster. So you can see we have these numbers. So they are the Airtel numbers, these are the Vodafone numbers, and last one is the one number from the Aircel. Okay, and this numbers belongs to, say, Pakistan. Okay, now let's say if I want to analyze this particular group or cluster. Now whatever I have copied, let's copy this and let's go to another graph and paste this information, fit this window in chart. So let's delete these IMEIs. Right now you can see these IMEI is common between two different targets. Now the information I have, I can do much more analysis. I can do the social network analysis on it. Like if I want to identify who are the individuals who can gather information quickly in this network, so I can find them. So like these are the individuals who can gather information in this network quickly. Who are the individuals who can pass the information in this network quickly? Like this individual is the one, and this is the same guy who was common in with 4 targets, and this guy was making only outgoing calls. None of my target is making any incoming calls to them. Okay, now let's we can also organize them into different layouts. Like let's see what is available in hierarchy. So how information is flowing from bottom to top. So this will provide us different strata where our targets are located in the network. Okay, now let's again do a layout organic. Now if other information is available, then I can bring that information also. Like let's say this is the number of methane. And some other information is available, then we can get those things also from the palettes. Okay, and if required we can add our own icons into these palettes also, and we can export these items as a JPEG or a PDF if required. So this is one way of visualizing this information, which basically helps investigator to identify certain hidden patterns which we cannot see, of course, in tabular data, or it's very difficult to visualize this information into a tabular data. Now another aspect of this data analysis is to go for so if you look here, there are various different types of reports, like identifying IMEIs. So if I look in IMEIs, I can see, say, this target has used 1 IMEI, but this target has used 7 IMEI, and we can also identify the make and model from the IMEI, which is on the basis of tag type allocation code. But we can also look for calls into different countries. Okay, like there is one call to Pakistan, let's say, who called and when he called. Like this call, guy called in and out to Pakistan. So similarly to, say, Saudi Arabia. Okay, so this call along with the latitude, longitude, and azimuth. So all this information will be available. Okay, now another important thing over here is geo analytics. So geo analytics will provide us a facility to analyze all of this information over a piece of map. Okay, so now let's see this information over a piece of map. Now so by default the layer which we load is from offline maps. So these maps are offline, they doesn't require any internet connection. They reside into the investigator's machine, because a lot of time the agencies do not have internet access on which they use these maps. But if required, we also have facility to load the web layers, like OpenStreetMaps and etc. other maps. So for example, OpenStreetMaps can be accessed, or Google Maps can be accessed. As well as we can also load the offline tile layers, which may be scrapped from satellite imagery providers or other service providers of satellite imagery. So here let's say I have these two targets, and if I want to plot their footprints, I can give them markers. Now this information will be plotted all, over a piece of map, and now we will be in a very easy to understand manner. We can see that how these individuals are placed, and we can zoom in and zoom out. So now if you look, so we can quickly see their distribution. Say this target has less footprints, and the other target in green is having much more larger footprint, even to the border which is neighboring to Pakistan. Let's say from here, where did he called? And this is basically the sector which we are calculating on the basis of the azimuth value which is provided by the service provider. And I can pull that, okay, what type of call it is and to whom this guy has called, and so all the related metadata can be exported out. Now another important thing is something about maps is the movement of target. So now let's plot the movement of the target. So this movement is basically from the historical information. So you can see how my target is moving from one location to another location, and you can see the date, time, and to whom and this individual has called. So this will basically generate animated part that how my target has called to different individuals over a period of time. Okay, so let's stop this. Okay, we can basically zoom in, zoom out into this. So there are other reports as well related to different aspects. So these reports have been designed by consulting different law enforcement and intelligence officers, and then they basically are point and click in nature, and they basically provide an interface of just to give them a quick overview of all these things. So for example, if we want to generate a report for briefing purposes, then we can do so. Let's select this particular number, let's apply the filter, come to reporting and say generate preview, or if required we can export a quick report in MS Excel format, which can be generated and can be given to the field officers very quickly. So this is the summary sheet. These are the mobile numbers, landline numbers, any international numbers which have not been identified. Okay, IMEI used by the person, location details, along with so all of them are in decreasing order of the frequency. So from which location person called, how many times, what are the day locations, what are the night locations, last call details, call type distribution, etc. And if required, this report can be exported into different formats like PDF, even PowerPoint, and other formats which are popularly used by the agency. So this is all about the processing of call data records or IMEI scans. So thank you for watching this video, and I'll be creating another video for some different modules of call data analysis and management system. Thank you for watching.